Really quickly, I want to go back to question 33 because, as somebody pointed out in the comments of that video, there's a cool little shortcut that I could have used that would have saved a lot of time. I'm not going to always go back and re-record videos every time somebody points out a clever solution in the comments, but sometimes I just can't help myself, and this is one of those instances. So big shout out, thank you to Saif, hopefully I'm saying that right, who let me know that we could have gotten this answer a lot quicker. So the idea in this problem is we're trying to find v prime, so we need to take a derivative. The problem is the equation of v that we need to take the derivative of isn't at all obvious. So we first have to derive this equation, then take the derivative. Deriving this equation involves integration. So we end up first using integration and then taking a derivative. That should have been a big red flag to me that maybe the fundamental theorem of calculus would apply. Right, I used this picture to come up with this equation for v, and after a few substitutions, I got here. I then went on to integrate to get this expression for v, and then take the derivative to figure out v prime. But what would have been a lot quicker, thank you Saif, is to take the derivative of this version of v, not this version of v. Why? Because loosely speaking, the derivative and the integral are going to cancel out, so I'll get my answer a lot quicker. So let's do it. V prime will just be equal to the derivative, maybe with respect to time, of this integral from 0 up to h, which itself is a function of time, of pi times, instead of writing 2r, since r is a fixed constant of 5, I could just write 10, capital H minus h squared, d capital H. What the fundamental theorem of calculus tells me, loosely speaking, is that if this is just a variable, the derivative and the integral cancel out, and I just change all the capital H's into that variable. I talked a little bit more about how that works and why that works on question number 5. So if you need a little bit of a review on the fundamental theorem of calculus, maybe go back and take a look at that video. But anyways, if I'm lucky enough for this to be a variable, derivative and integral are gone, change your letters and you're done. If this is a function, it's almost as easy. The only difference is because of the chain rule, when the derivative and integral cancel out, I don't just change the capital H's into little h's, I have to tack on an h prime. Hidden chain rule going on there. Similarly over here, I change the capital H into a little h, so I'd get h squared, but then I tack on an h prime. What I have here is an expression for v prime. In fact, it's equivalent to the expression that I later figured out way the hell down here, right? Distribute this 1/3 through the parentheses, and you get 10h prime minus h squared h prime. We jump directly from here down here, cutting out all this work here. It's a cool little shortcut. At this stage, to finish the problem, all we have to do is plug in values for h and h prime. They're the same values that I plugged in down here, 2 and negative 1/3. Do a little bit of arithmetic, and we're done. Definitely a lot quicker, which is important on a test like this where time is at such a premium.